In this section, we're going to take a look at two important rules for techniques of differentiation. We're going to be taking a look at the product rule and the quotient rule. So product rule, actually pretty easy, respectively. The product rule says that if you have two functions and you're trying to find the derivative, so let's just say we have d dx of a function f times a function g, all right? First of all, that's not equal to f prime g prime. All right, so just make that apparent that you just can't find the derivatives of each of those, unlike sums and differences. However, it's not too bad. The formula is going to be f prime g plus f g prime. All right, so basically you're going to find the derivative of the first function, find the derivative of the second function, and then just multiply them using this formula right here. Right? A strategy that I use is I define what f and g are, and then I find the derivatives of each of those, and then I just cross multiply them. So f prime g, f g prime, and then I just add them together. All right, so that might help you when we go through and do a couple examples. I'll illustrate specifically how I use that technique. All right, quotient rule. Quotient rule is a little bit more rigorous, but it's not too awful. Quotient rule, if you have the derivative of two functions that are being divided, so f over g. Now, first of all, let's make sure we understand it is not f prime over g prime, so you can't just find the derivative of each of those and divide them. So we do have a formula, and the formula for this is going to be f prime g minus f g prime divided by g squared. All right, so these are two formulas that we're going to be using throughout the course. Right? They're not too difficult after you've used them probably about 5, 6, 7 times. But initially, they might be a little bit difficult to understand. So let's go through. Let's work through a couple examples of the product rule. And by the way, I should have labeled that. This one is the quotient rule. So we're going to work through 2 examples of the product rule. Then we're going to work through 2 examples of a quotient rule, just to make sure you understand how these work. All right, so we want to find the derivative of a really basic sort of function. We have 10x minus 9x e to the x. All right, so one of the things we notice is that the first function does not have a product rule on it. Okay, we know the derivative of that function is just going to be 10. However, we do have this function, or this term in the function, 9x times e to the x, and that's a product. So here's how we're going to find the derivative. Let's start by defining f, the little function, to be negative 9x. And let's define the little function g to be e to the x. Because remember, we need f prime g plus f g prime is our product rule. We know that the derivative of negative 9x is just negative 9. We know that the derivative of e to the x is just e to the x. Okay, so go all the way back to the previous section, look at that list of derivatives. All right. In fact, I might suggest that maybe you have that somewhere handy to make sure you're okay with it. And we have our formula, f prime g plus f g prime. So now what we're going to do is we're just going to find the derivative of the big function. Now remember, we have this 10, and we're going to have f prime g. So we have f prime g, which is negative 9 e to the x. And then we have plus f g prime, which is negative 9x e to the x. Right? And that's going to be our derivative of this function. All right? So hopefully that makes sense to where all we're doing is we're just utilizing the product rule on the function, on the part of the function that does contain a product of two functions. And then this 10x, it's just the derivative is 10, so it just kind of carries down here. Right. Another example of a product rule is something like this, to where we have find the derivative dy dx if y is equal to 7x squared minus 14x plus 14. Now, some students, and not incorrectly, might try to distribute. All right, and that's not wrong, but it makes your life a little bit more difficult if you do that, because then you're going to have 2 product rules to do. Because you'll have a 7x squared e to the x and a negative 14x e to the x. So let's just do this. Let's just define these functions individually. And so we're going to define f to be the polynomial. So f is going to be equal to 7x squared minus 14x plus 14. And let's define g to be e to the x. Nice and easy. We know the derivative f prime is going to be 14x. So remember what you do is you just multiply the 7 and the 2 and then subtract 1. The derivative of negative 14x is negative 14. And then because 14 is a constant, it doesn't have a derivative value. So its derivative is 0. And we know the derivative of e to the x is e to the x. Nice and easy. Now we're going to use our formula for the product rule, f prime g plus f g prime. So we have f prime g, f g prime. And so dy dx is going to be equal to f g prime. Now be careful, 7x squared minus 14x plus 14. So this, I'm sorry, f prime g. So I started to write that backwards. So we're going to have, according to our formula, 14x minus 14 times g, which is e to the x. And we have to make sure that we use parentheses. All right, so that's 14x minus 14 parentheses e to the x plus fg prime. So that's going to be 7x squared minus 14x plus 14. And I have to squeeze an e to the x in there. All right. Now, unfortunately, this is not completely simplified, all right, because we want to make sure that we do distribute and then we try to collect like terms. So we're going to distribute this e to the x. We're going to distribute this e to the x. And so dy dx is going to be equal to 14x e to the x minus 14 e to the x plus 7x squared e to the x minus 14x e to the x, and then plus 14 e to the x. All right, so sorry we had to go into another line. All right, mercifully, we're almost done. And what you'll notice is that we have a positive 14x e to the x and a negative 14x e to the x. Those cancel. Notice also we have a negative 14 e to the x and a positive 14 e to the x, so those cancel. Right, so you always want to make sure at the end of the problem that you do try to clean it up and simplify where possible. And so finally, our derivative using the product rule is just going to be 7x squared e to the x. And remember what this does. This finds the slope at any point on y. Right? So that's important. We have to make sure that we remember what it is that we're actually finding. We're finding rates of change. Great. So hopefully this is a good introduction for you to be able to work with the product rule. In the next video, we're going to be taking a look at how to work with the quotient rule for derivatives.